Hello everyone, welcome to this channel. This question has been taken from Olympiad Pathfinder, Chapter 12, multiple choice question number 18. The question says, consider a cube as shown in the figure 1 with uniformly distributed charge in its entire volume. The charge is uniformly distributed throughout its volume. Intensity of electric field and potential at one of its vertex P are E0 and V0, respectively. A portion of half the size, half the edge length of the original cube is cut and removed as shown in the figure 2. Find modulus of electric field and potential at the point P in the new structure. So let us solve this question. We have collected all data over here. The cube is uniformly charged throughout its volume. Nothing has been mentioned about the material, but since it is uniformly charged throughout its volume, so we can say that it is an insulator or assume that it is an insulator, whichever is convenient. Let's say its side is A. We have assumed the side to be A. Electric field and potential at one of its corner P, as per question, is E0 and V0. When it was a complete cube, nothing was removed from here, so that has been shown here. Though this diagram is with one of the cube portion removed, but this V0 and E0 which has been written over here showing at P is when the cube was complete without any part or portion of the cube was cut and removed. So don't get confused. To find is modulus of electric field EP, E at P, and potential at P when a portion of half edge length means A by 2 side cube is cut and removed. So let's say Q was the total charge on the cube, and this was uniformly distributed as per question throughout the volume of the original cube. So we can subdivide the cube into 8 equal cubes of side A by 2. As shown in the picture. If you count 1, 2, 3, 4, 5, 6, 7, and 1 is behind this which we cannot say here. So here, because on 2-dimensional thing you cannot show the 3-dimensional thing entirely unless you rotate this and show it on the other side. Since this cube has been subdivided into 8 equal cubes of A by 2 sides, so we can say that each cube will be having Q divided by 8 charge on it. Let's say the potential at the corner P at the cube of side A when the cube was complete be expressed as Q by A multiplied by C, where C is a constant and not sure if it is 1 by 4 pi epsilon naught. But this CQ by A, if we are expressing the potential at P like this for the original cube, is equal to V0 as per the question. Similarly, the electric field at P can be approximated to express as C0 into Q by A square, and that will be equal to E naught from the question. E naught is given in the question that when the cube was complete, the E field at P was E naught. C naught here is another constant and not sure if it is equal to 1 by 4 pi epsilon naught. So following the equation 1, we can say that the potential at P due to each subdivided cube of A by two sides will be equal to V subscript P dash or P prime equal to C in place of Q. Each smaller cube, each subdivided cube is having Q by 8 charge and its side is A by 2. So we can write like this. So because of one of the smaller cube of A by 2 sides, the potential will be V naught by 4, as we can see here. Initially there was 8 cubes. Now there is one of the cube has been removed. So 7 cubes are left. So because of 7 cubes, what will be the potential at P? That will be equal to, due to the complete cube, what was the potential? It was V naught. And what will be the potential due to the 7 remaining cubes? Will be 7 times, or rather we should say that what if we remove the potential due to this small cube which has been removed from the potential due to the total cube, we will get the potential due to the 7 remaining cube. So the cube having the corner P and side A by 2 has been cut and removed. So now 7 cubes are left. Therefore, the potential at P will become V naught minus V naught by 4. So it will be 3 V naught by 4. Similarly, the electric field after removal of the smaller cube having the corner P can be approximated as total field due to the complete cube was E naught minus the field due to this cube which has been cut and removed. So that is C naught into Q by A divided by A by 2 square following this equation. Upon solving, we will be getting it as E naught by 2. So from 4 and 5, we conclude that answer A can be correct answer. So there are assumptions in this question. One thing is nothing has been mentioned about the material. So we have taken it as a perfect insulator. Or the charge has been arranged in free space in such a way so that it is uniformly distributed throughout the volume of the cube. And stabilized there, it is not moving away from there. Second thing, we know that the E fields are vectors. The vector sum modulus was given as E naught in the question at P, when the cube was complete having side A, right? So after removal of one section as shown in the diagram, the vector sum would have changed. if all the remaining cubes were not having the same direction for its E field at point P. So our assumption here is that the E field direction of all the subdivided cubes has the same direction. So this answer is an approximated based on assumption. So please bear in mind. Thank you.